Lesson 11-3, Areas of Regular Polygons. By the end of today's lesson, we will be able to find areas of regular polygons inscribed in circles. For the first vocab term we have here is the center of a polygon, which just simply refers to the center of a circumscribed circle. So I have an example here. This is a square inscribed inside a circle, so this would be the center of this polygon. And then the radius of a polygon is simply the radius of its circumscribed circle. So I can just go ahead. So this is the radius. And the apothem of a polygon is the distance from the center of any side of a polygon. So you can just draw the apothem. It'll be perpendicular to the side. So it's like the height of an isosceles triangle that has two radii as legs. So I'm going to go ahead and draw in the second radius. So these two radii will be the legs with the apothem. This is the apothem. Radius. So this makes an isosceles triangle. And the central angle of a regular polygon is the angle formed by two radii drawn to consecutive vertices of a polygon. So what we have here in the middle this would be called the central angle. With two radii drawn to consecutive vertices. So these are two consecutive vertices. Okay, example 1. In the diagram, ABCDEF is a regular hexagon with 6 sides, 6 equal sides, inscribed in circle G. Find each angle measure. Well, this is really simple. So for measure angle EGF, I know the entire circle is 360 degrees. I can simply just do 360 divided by 6 because there's 6 sides. So, and I can find this angle measure, which is 60 degrees. And measure angle EGH. Well, since this is a isosceles triangle, then this apothem here must be the angle bisector. So I can take 60 degrees and divide by 2, which is 30 degrees. And angle HEG. If this is 30 degrees, then this must be 60 degrees. Because I know that the apothem will hit the opposite side and form a right angle. So to show my work, I could do 180 degrees minus 30 degrees minus 90 degrees. 60 degrees. Example 2. In the diagram, FGHJ is a square inscribed in circle K. Find measure angle FKJ and measure angle KJF. So we're talking about this angle and this angle. Since we have a square inscribed inside, we have to take 360 degrees and divide by 4 to get 90 degrees. And this will equal to my measure of angle FKJ. So this is actually a 90-degree angle. And since we have an isosceles triangle here, I know that this would be my angle bisector. So this must be 45 degrees. Therefore, measure angle KJF must be 45 degrees. Theorem 11.11. The area of a regular polygon. The area of a regular n-gon with side length S is half the product of the apothem A and the perimeter P. So we have another formula here. For any regular polygon with n sides, we can just take half and multiply by the length of the apothem and multiply by the perimeter. Or we can write this as a equals half times a times n times s, where n is the number of triangles and s would be the number of sides. Example 3. A wooden coaster is a regular octagon with 3 centimeter sides and a radius of about 3.92 centimeters. What is the area of the coaster? So, to do this, we need to first draw one of these triangles, and we need to find the length of the apothem. So, to find the length of the apothem, we can use the Pythagorean theorem. So I'm going to let this be x, and then plus 1.5 squared, which equals to 3.92 squared, and then x should be about 3.62. So this is your apothem, and then we need to find the perimeter of this regular polygon, which is just equal to, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, it's our regular octagon. So 8 times 3, 24 centimeters. And then we can go ahead and use the formula. Area would just be half times 3.62 times 24, which is about 43.46 square centimeters. Example 4. The radius of the regular pentagon is about 6.8 inches. Find the area to the nearest square inch. So this is another practice. So I'm going to draw in one of these triangles. And if I draw the apothem, then this will make 4 each. And I'm interested in finding the length of the apothem. So I'm going to again use the Pythagorean theorem. X squared plus 4 squared equals 6.8 squared. So x will be about 5.5. And then now I want to find the perimeter, which is just equal to 5, so there's 5 sides, times 8, it's 40, and then 3, area equals half times 5.5 times 40, which is about 110 square inches. Example 5. A regular nonagon is inscribed in a circle with radius 5 units. Find the perimeter P and area A of the nonagon. Okay, we have limited information here. So perhaps we need to use angle degrees and trig to find the side lengths. So I know that I have an isosceles triangle here, and I know this polygon is inscribed in a circle, so I can find the angle measure of KLJ. So that would be 360 degrees divided by 9, because there's 9 sides of this regular nonagon. So that makes 40 degrees. If this is 40 degrees, then this angle bisector, this apothem will cut the angle in 2 halves. So this must be 40 degrees. I'm sorry, 20 degrees. So measure angle MLK is equal to 20 degrees. Then I'm going to use sine. Sine 20 degrees equal to opposite over hypotenuse. So MK over 5. And using your calculator, MK should be about 1.71. And then I'm going to use cosine 20 degrees, which is adjacent over hypotenuse. So LM will give me the apothem, the length of the apothem. So LM over 5. So cosine 20 degrees times 5 will give you about 4.7. So now that we have the lengths, then we can go ahead and find out what this area of this nonagon is. So again, we have our apothem, so that's done, and we need to find out what the perimeter is. Since there's 9 sides, I need to times that by twice MK, because MK is only half the length of JK, and JK represents the length of one side of the nonagon. So 9 times 2 times MK is 1.71. And then after you multiply these numbers together, it should be about 30.78 units. And then area, half times A times P, and the apothem will be 4.7, perimeter 30.78, and this will be about 72.33 square units. Example 6. Find the perimeter and the area of the equilateral triangle inscribed in circle F. So this triangle here, we have limited information. We don't have the side lengths or anything, but we can still first find the angle, central angle measure by taking, so that would be GFH, and by taking 360 degrees divided by 3, so that's 120 degrees. So if this is 120 degrees, then half of that will be 60 degrees. So measure angle GFJ would be 60 degrees. So this forms a 30, 60, 90 triangle. So, and I could take 6 and divide by 2 to get 3. So FJ, which is the apothem, would be equal to 3. And then 3 times JG would be equal to 3 times square root of 3. So now I'm ready to find the perimeter. I need to take 3 times twice JG. So this will be about 31.18 units. And then the area of the triangle will be half the apothem, which is 3, times the perimeter. So that would be about 46.77 square units. And here's a summary of how to find areas of regular n-gon with any of these given information. So the key strategies here are that you can use Pythagorean theorems, special right triangles, and trigonometry to solve for the areas. And these are just the given conditions when you know the number of side lengths of the regular polygons and the matching examples that we just did above.